Good morning, physics and active physics. Today, your assignment's going to be to work with the silly speed, distance, and time problems. So the last 2 days you should have completed your notes from the PowerPoint on one-dimensional kinematics. And now you're going to take that knowledge and apply it to solve some speed problems. Physics, you're going to complete all the problems 1 through 17. Active physics, you'll complete problems 1 through 12. And as you'll see here in a minute, I'm going to do at least I'm going to do one example, number 12, just to show you how you should complete the problems. All right, so again, you have attached these silly speed, distance, and time problems, but there's not a lot of room to actually do the work. So what you're going to do is you're just going to use that sheet to get the information. So with Kami, you have the option of creating a blank sheet and just go ahead and title it Silly Speed Problems. Make sure your name's on there somewhere, and then you just get off to solving the problems. And remember, for these problems, you're going to be using your magic triangle to solve velocity problems. So again, that's just going to be the distance over the time. All right, so when you wind up opening it up and looking at number 12, so that's going to help both classes out, at least one problem. The problem, I'll just read the problem verbatim and then we'll pull out the information and then solve. So Bart Simpson is standing 150 meters from a monkey at a zoo, making faces at the monkey as he watches it eating its daily bananas in a tree. The mischievous and muscular little monkey gets mad and hurls an unripe green banana at Bart. If the banana travels at a speed of 100 meters per second, how much time does Bart have to move? So again, we're going to pull out the information. So we're looking for the given values and trying to figure out what's missing and solve for that. So the first thing is Bart is standing 150 meters. So if that's a distance, so your distance is going to be 150 meters. And again, each problem should be done exactly how I'm doing it here. The next value that it states is if the banana travels at a speed of 100 meters per second. So you have a velocity 100 meters per second. And then it says right at the very end, how much time does Bart have to move? So time would be the value that we're looking for. And again, if you come over here and if you were to cover time, you can see you would need to take your distance and divide it by your velocity. So the time would equal your distance divided by your velocity. Now we can just plug in the values. So 150 meters divided by 100 meters per second. And these meters will wind up canceling because we know that the unit for time is going to be in seconds. So then when you just go ahead and divide through here, you're going to wind up with 1.5 seconds. All right, for these problems, I am not expecting you to put them in the correct sig figs, but in this case, you would have to basically round it to 2 if you wanted to, but you're not required to. So it wouldn't be that, it would just be 2 seconds because this value has 1, that value has 2, and we'd have to put our answer in the one with the least. But again, don't worry about sig figs, just go ahead and put your answer. Make sure, this is important, you have to have your unit. So remember, time is going to be in seconds. Velocity or speed is going to be meters per second, and any distance is going to be in meters, right? And if, all right, yeah, so you're going to go ahead and work through the problems. Any questions, email me, and tomorrow I'll have an assignment posted that'll be more along the lines of questions and some vocab for speed. All right, thank you. Have a good day. Bye.